Good morning. Good morning. Okay. Welcome. You have made it to Thursday at reInvent. All right. Yeah. Woohoo. So you're in SDG 215. This was not a session on the original catalogs, partly because of the things that we're going to talk about and we'll cover. The session is going to cover protecting your data and lowering costs with EBS snapshots. With me is
Venki Nagapudi. I'm a product manager with the EBS Snapshots team.
And my name is Ashish Palekar. I am the general manager of the Snapshots business. So my role is listening to feedback from you and making sure we're building the right things to make sure we're meeting your needs. So again, excited to have you here. Here's what we intend to cover today. So our agenda is we'll go through an intro on EBS snapshots, cover some basics because those questions we see again and again, super important to sort of go through those. Venki will cover what's new with snapshots. I'll cover EBS Direct APIs and Data Lifecycle Manager. Then we'll cover snapshots and Outposts, some announcements that some launches that we've made there. We have a lot to get through. At the end, we will step by, take questions. Please stop by. Would love to hear your questions. We have a lot to get through, so let's get started. Okay, so when we think of storage within the AWS portfolio, obviously we have the core offerings around object, block, and file. Object is S3 and S3 Glacier. With file, you have EFS, the FSx family, to which we added two new offerings this year, FSx ONTAP and FSx for OpenZFS, which launched at reInvent just this week. Then we think about the hybrid edge storage pieces, things like Storage Gateway and the Transfer family, things like the Snow family and Outposts. And then we have a slew of data services. Think AWS Backup, think S3 Storage Lens, S3 Lifecycle Management. And within that space of data services is where snapshots and Data Lifecycle Manager fit. And so we're pretty excited to talk about those capabilities. But before that, let's just quickly review the block storage offerings. Within AWS, when we think of block storage offerings, we really think of three things. So on the EC2 side, you have Instance Store, and you have Instance Store with SSDs and HDDs. So think i3, i3EN, that family, D3 being the HDD side. On the SSD side for EBS, we have our SSD offerings, GP3 and IO2. And then on our HDD side for EBS, we have ST1 and SC1. So what then is a snapshot? So if you imagine an EBS volume and an EC2 instance, they are within an availability zone, then a snapshot is a point-in-time backup of that EBS volume. That backup, that point-in-time copy, is stored on S3. And its properties are that it's incremental, meaning that you will store only the changed blocks. We'll look at exactly what that means in a slide or two. They're crash consistent. We'll go into that as well, meaning that completed IOs are persisted in the snapshot, and then they can be shared and copied across accounts, and we'll cover that as well. Before we dive into each of those, how are snapshots used? And this is what customers tell us. It's pretty exciting to see how the use case has evolved. So the first use case is around EBS backup and disaster recovery. So you have a volume, something bad happens to the volume, you have a snapshot. Using that snapshot, you can create an EBS volume. Not only that, you can then copy that snapshot across a region, across accounts, or you can share it, and you can copy that snapshot over or share that snapshot and instantiate volumes. So that's use case one. The second use case, which we started seeing, is customers using for refresh of their dev test environments, scale up, and data handoff workflows. So what do we mean by that? So imagine running an analytics job from that on an EBS volume. From that, you take a snapshot, create an army, and then for the next day's test dev workloads, you use that army to spawn multiple EBS volumes. And that's a pretty common scenario that we see customers deploy on. Another scenario is to take that analytics workload or changed workload and then use snapshots to copy or share that across accounts, either within the same organization across different organizations, but giving others access to that data so they can manipulate it to understand what else to do with it. That's a pretty common workflow that we see as well. Our third scenario is where we see non-EBS backup and migration. We'll cover that today as well. So in this scenario, customers have their corporate data center with disks in them, and then using EBS Direct APIs, they are creating snapshots and creating point-in-time copies or point-in-time backups. And that's another scenario that we've started seeing, especially with Direct APIs, and we'll go into why. And across these three use cases, we have a wide array of customers and partners. And again, on behalf of the team, and just wanted to thank each and every one of you and our customers and partners. Truly meaningful in terms of helping us make progress. And in fact, a lot of the innovation we drive comes from feedback from you, so thank you for that. All right, let's dive into the basics. I said snapshots are incremental. So how does a snapshot work? So imagine you have an EBS volume. Say it's a completely empty EBS volume. Nothing's written to it. If you now take a snapshot, it's an empty snapshot. And you have no billable data, and essentially the cost in that scenario is zero. Now, for that 1 terabyte EBS volume, let's say you write blocks 1, 2, 3. If you now take a snapshot, your first snapshot will have blocks 1, 2, 3, and those are your billable blocks. Let's say blocks 1 and 2 get deleted. Let's say blocks 4, 5, 6 get added. You now take a snapshot. Your snapshot 2 is going to consist of a reference to block 3, because it's in the previous snapshot. And you'll have blocks 4, 5, 6 in the second snapshot, and that's now your billable blocks for snapshot 2. Let's take this further. Let's say you add blocks 7, 8, 9 in the volume. Now take a snapshot. What's going to happen? 3, 4, 5, 6 are going to be reference blocks, and then 7, 8, 9 will be your new blocks, right? And so your billable blocks are 7, 8, 9. Okay, so far with me? So now let's imagine that snapshot number 1 is deleted. What should happen? Block 3 now becomes a billable block, and that's the change that happens. So this is super important when we are talking to customers, and in fact, some of the capabilities that Venki will cover a little bit later. This model of incrementality and how changed blocks move is important as you're thinking about snapshots and the cost of snapshots. So what are the key basic things to remember? Every snapshot has access to the full set of data for that backup. All the snapshots are stored incrementally, and snapshots are charged only for the storage written. Item 2 in that same vein is, what is the consistency of snapshots? So we say EBS snapshots are crash consistent. So what does crash consistent mean? Crash consistent means that snapshots will contain the blocks of completed I/O operations. So any I/O operations on EBS that you have received an acknowledgement for, those will be stored in the next snapshot that you take. Data that is not flushed to the disk, so example, data that's resident in the application buffer or the file system buffer or buffer caches, that does not go into the snapshot because it's not yet gone to the disk. The mental model we have around crash consistency is this is similar to pulling the power cord on a server. And whatever is the state on the disk, that is crash consistent. Application consistency, on the other hand, is where all the application data, be it in the application cache or the buffer cache or the file system cache, is all flushed to the disk. To achieve this, you have to halt IOs, take a crash consistent snap, halt IOs, flush IOs, and take a crash consistent cut, and then unfreeze or unblock as soon as the snapshot creation is completed. And we'll show you scenarios in which that's supported with EBS snapshots as well. So specifically, EBS supports multi-volume crash consistent snapshots. So what does that mean? Let's say you have an EC2 instance, and an EC2 instance has multiple EBS volumes that are attached to it. Then you can, with a single API command, it's called create snapshots, TS, the plural command, you can take a crash-consistent cut across all those volumes and store different snapshots for those volumes. And part of it is it allows you to have a crash-consistent cut. So the slide says, and one of the reasons we recommend this is, you need to separate your boot volumes from your data volumes. And part of the reason to do that is, if you want to record your application state across your multiple volumes, you can then avoid taking a snapshot of the boot volume. So then if you want to recreate the application state, you just restore all those crash-consistent volumes, and you're off to the races. A common scenario in which we see that is customers who are raiding multiple EBS volumes for performance reasons. Or you have a data file, a data volume, and a log volume for your database. This becomes a super common scenario in which customers take multi-volume crash-consistent snapshots. Windows has a service called Volume Shadow Copy Service, called VSS. And what VSS allows you to do is essentially take an application-consistent snapshot cut across volumes. So VSS manages the disk operations, and you can pause file writes and take when a backup is in progress. So any VSS-enabled snapshots of EBS volumes, through our AWS Systems Manager, you can use the run command to get access to that. And the benefit of VSS in Windows operating environments is that you don't need application-specific backup solutions, and can use VSS just to take application-consistent snapshot cuts. So again, if you need application consistency in a Windows environment, this would be one way to achieve it. All right, let's talk about encryption, something we care deeply about. So with encryption, EBS, we integrate with our key management service, KMS. And under the hood, we use AES 256 encryption. We also use support customer managed keys, CMKs. Some important things to think about when you're thinking about encrypted EBS volumes. Once an EBS volume is encrypted, data at rest inside the EBS volume is fully encrypted. Data that is in motion between the instance and EBS, that is encrypted. Any snapshots you create from that volume are also encrypted. And any volumes you create from those snapshots are also fully encrypted. The other thing that happens is you can then take that snapshot and you can encrypt. You can take an unencrypted snapshot, and because snapshots can be copied, you can encrypt that snapshot during the copy, right? So you can take a snapshot, copy it, and make it an encrypted snapshot. And then you can re-encrypt a snapshot as well while you're doing a copy. And I'll walk you through all those scenarios and why they become useful and what we are doing there. One of the things to think about, and this will go into some of the security stuff, is snapshots are different than EBS volumes. In what way? Snapshots are shared across accounts. They can be copied across accounts. They can be copied across regions. They can be copied within accounts. And last but not the least, you can create armies. And so the security characteristics and the sharing characteristics make it such that you have to think about your security posture on snapshots. And we'll cover some of that today. So how do you share a snapshot in an army? So on the EC2 console, you can go in. There's a tab for modify permissions. If, like me, you like the CLI, here's the CLI command. You can use the modify snapshot attribute to actually figure out how to change the permission. And there you can see the attribute you want to set. Then in the console, and I'll cover the CLI part as well, you get the option to either share it as public or private. I'll talk about that. For most of you, for most situations, you should use private. And if you specify private, then you have to specify the account number that you need to share the snapshot with. Public sharing is a reasonable use case. As an example, if you are an AWS Marketplace army, that is a reasonable use case to share public snapshots. But for almost every other use case related to either a non-Army use case or even an Army use case within an organization, share it with specific accounts. Last thing that often customers ask us about, if you want to launch a volume from a snapshot, do be sure you have a copy of that snapshot in that region, because otherwise you won't be able to launch a volume from a snapshot. So how do you find out if a snapshot is public? Another question that customers ask us. So if you go to the console, you can look at the permissions tab for a snapshot, and that will tell you if this snapshot is public. Again, if you like JSON or XML output, then you can see the create volume permission, and that will show you a group equals all, which will tell you that the snapshot is shared. All right, copying snapshots. So when a snapshot is copied, either across regions, within an account, across accounts, the snapshot encryption is protected by, snapshot is protected by Amazon S3's encryption during the copy process. As we talked about before, unencrypted snapshots can be encrypted during copy. Encrypted snapshots can be re-encrypted during copy. This is the next thing is something that a lot of customers get tripped up about. The first copy across regions, much like taking the first snapshot, is a full copy. Snapshots after that are incremental. Now, even encrypted snapshots, so long as you use the same CMK, are also incremental. And you need the same CMK to support incremental copies. But that is pretty cool to actually get incremental copies on both sides of the copy. So how do you encrypt or re-encrypt? Again, Windows to the EC2 console, you have the copy tab. In the copy tab, you have the option to turn on encryption, or you could change the encryption key right below it. Here's the CLI command that you would use to go run it. So in this case, you have a copy snapshot that is being re-encrypted with a new KMS key. So copying snapshots across regions. This is something that we are seeing become increasingly popular. And one use case for that, or one scenario that customers do it in is they'll copy the snapshot across accounts and across regions. Then in the second region, they will lock down the resource level permission so that very few, if anyone, has access to that snapshot, including they'll restrict access to that snapshot. And so the reasons to do that are two. One is by copying the snapshots across region, you are protected against any regional level events. So that's one. The second is with the permission lockdown, you can block malicious or unintentional access to data. We launched 3 features a couple of years back to make encryption easier for our customers. The first one is launching of encrypted volumes from unencrypted snapshots or armies. How many of you have tried that feature? Show of hands. 1, 2, 3. More of you need to try it, and I'll walk you through why. Sharing snapshots encrypted with custom CMKs across accounts, I'll walk you through that. And then how to set encryption by default for EBS at an account level. How many have set encryption by default for EBS? Only 1. Way more need to try, 2, okay, good. Way more need to try that and set it. So we'll go through why about that as well. Let's talk about encrypted volumes from unencrypted snapshots or armies. All right, here's what you used to do previously. You had an unencrypted snapshot or an army. You would copy that snapshot, encrypt that snapshot or army, and then launch an encrypted volume for that snapshot. Similar steps if you needed to change the encryption on a snapshot or an army. After this change, here's what happens. You have an unencrypted snapshot or an army, you can directly launch an encrypted Amazon EBS volume, right, without having to copy, saving you time and cost. And that's the CLI command to go do it. But the goal there is you're directly launching a volume without having to create a copy. All right, let's talk about sharing encrypted snapshots or armies across accounts. So in this one, you had a snapshot and an army that was encrypted with a custom CMK. You'd copy those snapshots across accounts, and then you would launch a volume. Note that only snapshots that are encrypted with custom CMKs can be copied across accounts. After this change, let's say you now have a snapshot and an army that is encrypted with a custom CMK. you can directly share that snapshot and launch a volume. No more copy needed to make sure that you can launch a volume. Again, this works with snapshots that are encrypted with custom CMKs. It doesn't work with AWS managed CMKs or what we call default CMKs. That's important for you to remember. So how do you do this? You go to the KMS console. In the KMS console, you select the key to share. And this is the output for the key to share. Once the key is shared, then you can, in this case, I did a run instances. With the run instances, you have the block device mappings. And the block device mapping now refers to the new key. And in that sense, you have access to the key. You can take that snapshot and just launch your new encrypted volume. The really cool thing is combining these two features. OK, what does that mean? Let's say you had an unencrypted snapshot in Army, and you wanted to launch an encrypted volume in a different account. Here's what you would do previously. You'd copy that snapshot across accounts, you'd encrypt that snapshot, and then you would launch a volume. Okay? Now, with both these features combined, you take an unencrypted snapshot in Army, share it across account, and you can directly launch a volume. No more copying, and no more waiting to create a volume. So again, saves you cost and effort. Again, for this, you need the snapshot either that is unencrypted or a snapshot that is encrypted with a custom CMK, but it directly allows you to launch volumes with your encrypted key. The big one is account-level encryption by default. So one of the patterns we saw with customers is they would create volumes in accounts. And when you create volumes in accounts, you could have encrypted volumes and unencrypted volumes. Customers would set IAM policies to prevent the creation of unencrypted volumes and snapshots in their accounts. In one case, what we actually saw was customers were, when unencrypted volumes were created, take a snapshot of that volume, encrypt it, create an encrypted volume, reattach it to the instance, and delete the unencrypted volume. So pretty complicated workflows to just make sure that volumes were encrypted. So what we've done is take that scenario, build a single account-level regional setting, and from that point on, any newly launched EBS volumes and snapshots are fully encrypted. So if you haven't done this, please do it. And here's my last pitch of why to do this. How do you actually achieve this? Go to your EC2 settings, look at your EBS settings, and the EBS setting says, do you want encryption by default turned on? Click that, select your key, and that's it. Right? From that point on, all new snapshots and volumes created in the account will be fully encrypted. So in case you haven't already looked at encryption by default, please do. All right. Now to talk about the new features, Venki, you want to take us forward?
Thank you, Ashish. So I'm very excited to be presenting two new features to you. The first one is Recycle Bin for EBS snapshots. We launched this feature just earlier this week on Monday. What it helps you do is to protect your EBS snapshots from accidental deletions by recovering from them, right? So you all use EBS snapshots to back up and protect your volumes. But many of you have come back and told us that there are times when you accidentally deleted your snapshots either because of a user error or a script error. In such cases, it's hard to deterministically undelete a snapshot and until now, right? With the feature that we have created for you with Recycle Bin, you can store these deleted snapshots for a configurable period of time, and you can recover them as long as the retention period has not expired. So let me take you through the details. So first, at a high level, you can specify the time you want to keep your snapshots for in the Recycle Bin, and automatically all snapshots that are deleted will move into the Recycle Bin. You specify retention rules, and in those you can either say, I want to have all my snapshots protected or some that are tagged that are protected. And You can recover a snapshot anytime from the recycle bin as long as the retention period has not expired. A snapshot in the recycle bin is pretty much similar to the snapshot that's outside. So we made billing simple by keeping the snapshot price the same, right? And you can restrict access to who can create the rules and who can access the resources in the recycle bin. And I'll tell you how to do that in the next few slides. So first, how does it all work? It's very simple. You create a retention rule or a couple of retention rules. You have a choice of creating an account level rule or a tag level rule, and I'll explain the difference between the two. Once you do that, any snapshot that is governed by any of these rules on deletion will move into the recycle bin and will remain there until it is permanently deleted at the end of the retention period expiry. And meanwhile, during that time, you can always recover the deleted snapshot and use it for any regular use cases, such as creating a volume out of it. So how do you do this? So let's start with how to create a rule and how to manage these rules, right? So 3 things you need for creating a rule: the retention time that you want to specify for your snapshots. The second, whether it's an account level rule, in which case you're protecting all the snapshots within your account in a particular region. Or you have tag level rules, in which case if your snapshots have a particular set of tags, you can use those tags and say, for these tags, I want to go and protect the snapshots and not all the snapshots that are in my account. Right? So you'd use the account level rule if you have a critical account that you want to protect all snapshots for. But if you want to optimize on cost, then you can use the tag level rule. And I'll take you through how you create these rules. So here's an account level rule. This one, I want to protect all the snapshots in my account for 2 days. And so I can either use the create rule CLI call and specify the retention period, or I can use the console. And we have a very nice console that you can use, a new console for recycle bin that you can use to specify and create the rule. So it's simple as that. Then here's an example of one where you have a tag level rule. In this case, I want all my snapshots with the tag rbin test1 to be retained for a day in the recycle bin after deletion. So I use the create rule or the console, and I can go ahead and do this. Once you've created the rules, it's easy enough to list all the rules in the console and see them. You can also use CLI calls. You have list rules. Also, you have a get rule if you want to dive deeper into the rules that you've created. Now that you have the rules, how do you manage the snapshots in recycle bin? So here I show the snapshots console on the top, and I have 4 snapshots. And a recycle bin console with the resources listed. Right now, I don't have any resources in the recycle bin because I haven't deleted anything. So let's say I go ahead and delete a snapshot. So in this case, I delete snap test 4. And this happens to have a tag associated with it, dev resource tag, right? So either a tag level rule will kick in if there's one, or an account level rule, so that when I delete the snapshot, it should move into the recycle bin. So let's take a look at the rule I have for the dev tags. So any snapshot that's tagged with dev would move into the recycle bin and would remain there for 3 days before it's permanently deleted. So with this rule, what happens is when I delete the snapshot, it moves from the snapshot console into the recycle bin console, and it'll show up there and it'll stay there for 3 days until it's permanently deleted. So I realize I made a mistake. I shouldn't have deleted the snapshot. So it's easy enough for me to then recover the snapshot. I use the CLI call restore snapshot from recycle bin, or I use the console, and the snapshot, on a restore will immediately move into the snapshot console, right? And once it moves there, once the snapshot is recovered, I can use it to create a volume. Like I can instantaneously go and start using it to create a volume like it's any other snapshot. So easy to use this product. One of the things that I want to talk about is the recycle bin permissions. How do you manage this? So all the actions that are related to creating the rules and so on can be managed by a special IAM admin role for Recycle Bin, whereas all the regular snapshot actions such as creating and deleting snapshots can be assigned to a snapshot user role using IAM policies. So here's an example of a Recycle Bin admin role. So in this, as you can see, all the actions related to the APIs for creating rules, deleting rules, updating rules, they're all assigned to the Recycle Bin admin. And all the snapshot users, they can go and create snapshot, delete snapshot, and so on. They can also list snapshots in the Recycle Bin, restore snapshots from there, but you can optionally move these actions to the Recycle Bin admin role as well and make it a bit stricter in terms of protection. So that's the feature, and if there are a few other considerations here. You get a lot of rules per account, 250 rules and 50 tags per rule that you can specify. You can specify both tag level rules and account level rules for your snapshots, but your tag level rules will always take precedence over the account level rules. If you have multiple tag level rules, then the one with the longest retention time will be applied to the snapshots. As with snapshots that are deleted, fast snapshot restore is going to be disabled on delete, and you can re-enable later on recovery of the snapshot. Sharing is disabled when a snapshot moves into the Recycle Bin, but all shared permissions are retained so that when you recover the snapshot, you can then reshare the snapshot. Finally, other than restoring a snapshot or recovering a snapshot from Recycle Bin, the only other action you can do is add, delete, or modify tags. That's Recycle Bin. Then second product that I want to talk about, I'm very excited about, is EBS Snapshots Archive. This is the first new tier we have created for EBS Snapshots in 13 years. And this is a product that's essentially come out of customer ask, completely innovated on your behalf. So many of you have come and told us that you want to keep your snapshots for a long duration of months or years for regulatory or compliance reasons, or just because you stored these snapshots at the end of a project and you want to reuse them later. You told us that you don't generally restore these snapshots as often, and that you don't mind having slower restore performance as long as you can get lower storage costs. It's exactly what we are providing with EBS Snapshots Archive. So in this tier, once you create a snapshot, you can move a snapshot into this tier. You will have to store it for a minimum of 90 days. So it is for long-term retention. A key difference from snapshots, incremental snapshots in standard tier to snapshots in the archive tier is that these are full snapshots. They store all the blocks that were written to the volume at the time of creation of the snapshot. So they're good for compliance use cases where you need to store these full snapshots. Right? And you first need to retrieve a snapshot from archive before you use it for regular operation, like creating a volume. And retrieval time will be anywhere from, let's say, 24 to 72 hours, with the largest snapshots taking up to 72 hours. Good part is you get 75% lower storage costs at 1.25 cents compared to snapshots of 5, and then 3 cents per gigabyte for retrieval charges. So we expect that this is the tier that you would want to use for long-term retention of your rarely used snapshots and save on costs. How does this work? It's actually very simple. Once you create a snapshot in the standard tier, you have an API call to archive the snapshot. It creates a full snapshot and then moves it in the archive tier. And restoring a snapshot is, again, a simple API call. You restore a full version to the standard tier, and you have a choice of either a temporary or a permanent restore. I'll go into the details. So very simple set of APIs. How do you archive snapshots? So let me show you using the console here. So here's a list of snapshots that I own. They're all in the standard tier, right? And I can always archive a snapshot that's in the standard tier. So in this case, I choose this snapshot. And I either call a modify snapshot tier CLI, or I can do this directly by clicking on the actions in the console and archiving the snapshot. So I'm told that this will create a full snapshot, and I'll not be able to access it unless I first restore it. So I'm fine with that, so I go ahead and archive the snapshot. And archival could take anywhere from a few minutes to a few hours, depending on the size of the snapshot. And I use describe snapshot tier status to figure out the progress, or I could also take a look at the tab on the console to see how the tiering is progressing. And once a snapshot is tiered, it's going to be in the archive tier, and it'll remain there unless you go and retrieve it. So let's take a look at the retrieval, right? How do you restore snapshots? As I said, you first need to retrieve a snapshot from archive before you use it for anything like creating volumes. It could take up to 72 hours to restore a snapshot from archive, but the 72 hours is really for a 64 terabyte snapshot. So if you have snapshots that are smaller, like in a few hundred gigabytes, it will take a few hours. So you have the option of temporarily restoring a snapshot. So let's say you want to restore it for a week in order to go create a volume out of it and examine the contents, etc. So what happens is a permanent copy of it stays in the archive tier, and temporary copy shows up in the standard tier, right? And then it'll tier back after a week, right, or whatever time you specify. Permanent restores, you can do these as well, where you take a snapshot and restore it into permanent tier, into the standard tier permanently, but keep in mind that there is a 90-day minimum retention period in archive that will apply even for permanent restores. Right? So how do you do the archive? So let me walk you through the scenario. So here is an archived snapshot. Only archived snapshots can be restored. And the way you do it is by using a restore snapshot tier, and you can either restore permanently. So in this case, I have the option here on the console to restore permanently, or I can use a CLI call and specify permanent restore as an option, or you can restore temporarily as well. In this case, I want to restore for 3 days. Go ahead and use the CLI call or the console and restore it. Once I restore it, similar to the archival, you can use the describe snapshot tier status to figure out how much the snapshot has progressed, tiering has progressed, or you can use the console as well. And in this case, once the tiering is completed, the snapshot is in standard tier and will be there for 3 days before it moves back into archive. So a very simple product to use. One modifies snapshot tier for archival and another for restore. So 2 API calls, but you want to understand what are the snapshots you want to archive, what are the ones you don't want to archive. So let me take you through some of the ones that you could archive. So last snapshots of inactive lineages, full snapshots that you might want to keep for compliance reasons, and snapshots with high change rates, 25% or higher, you can go ahead and archive these. And let me dive into each of these cases. So an inactive lineage is one in which you're not writing to the volume anymore. And so let's say the volume is dormant, you've taken a last snapshot of that volume. That last snapshot contains all the bytes that you've written into the volume at the time you took the snapshot, so it's a full snapshot. Now you could choose to keep this in standard tier, but if you move it into the archive tier, you are going to save 75% in terms of costs, as long as you want to retain for 90 plus days. So certainly this would be a good one to archive for cost effectiveness. Second is a full snapshot that you might need for compliance. So we heard from customers that they take monthly, yearly, quarterly snapshots of, let's say, their databases and want to keep full snapshots of these volumes for long term. That's what EBS Snapshots Archive does really well. You take full snapshots which don't have any backward or forward references. They're standalone entities. You can retain them for 90 plus days, and you get lower costs by keeping them in the archive tier. So certainly, if you want to archive for compliance, this is a very good use case. Finally, what about snapshots you just want to archive for cost savings, right? So let me take you through a scenario where, let's say you have this lineage, you have a 100 gig volume, You take a snapshot of it, and actually take 3 snapshots. Second one has a change that's 30 gig, right? And third, where you add 20 gig. Your question is, should you archive the second snapshot? So this has changed 30 gig over the previous snapshot, so the change rate is 30%. If you keep it as a snapshot, then you incur 150 cents in this case as costs. If you go and archive it, you actually have lower cost per month because it's 125 cents, and that's 30% cost savings. So certainly, if your snapshots have 25% change rate or higher, then you can go ahead and archive and save on costs. There are some cases where you don't want to archive for cost reasons, right? And some of the cases are snapshots with less than 25% change rates, the first and last snapshots of active lineages. So let's take each of these cases. Here's the same picture that I showed, except that this time the second snapshot has only changed 20%, right? If you archive this snapshot, you will actually have higher cost because there's not enough of a change in the snapshot. So we don't recommend archiving snapshots less than 25% in terms of change rates for cost reasons, right? Now we take a look at the first snapshot of your lineage. This is a snapshot. It's always going to be a full snapshot, as Ashish explained. And if you go and archive this snapshot, it also happens to be the most referenced snapshot. A lot of the snapshots that come later will reference the first snapshot. So if you archive it, then you lose out on the backward references. Also, the next snapshot is going to be full, and so you lose out on the incrementality aspect of snapshots. So we don't recommend archiving the snapshot for cost reasons. Same thing, if you take a look at the last snapshot, it's the one that is most frequently accessed because it's the latest one. You're likely to use this to create volumes, and therefore, if you go and archive it, you'll have to first retrieve it before you use it. So that's more time and higher charges. So also you lose out on forward references. So we don't want you archiving these snapshots for cost reasons again, right? One of the questions you might have is, how do you find the change rates of snapshots? This is where Ashish will talk about it, but you can use EBS Direct APIs to figure out how much, how big each of these snapshots are. So in this case, let's say I want to compare snapshot A and snapshot B. I can go and figure out the sizes of the snapshots by using list snapshot blocks. And then I can figure out what changed in snapshot A, snapshot B over snapshot A by doing a list change blocks. And the ratio of that is what the change rate is. So as long as the change rates are favorable, you can go ahead and archive the snapshot. A few other considerations: only owners can archive snapshots. You can't archive shared snapshots. When someone archives a snapshot, the owner archives the snapshot, FSR and sharing are disabled. They need to be re-enabled upon restores. And then you cannot archive snapshots that underlie AMIs. And recycle bin is supported for snapshot archives as well. So this is a brand new tier. You might have a lot of questions, so please do visit our snapshots webpage to get more details. And before I finish, shout out to some of the customers and partners who have already previewed this product. And here's what they say on why they want to use it. So Stem Cell Technologies wants to store data for a long duration of several years for regulatory requirements. So they like the ease of use and the lower cost of EBS Snapshots Archive. Zillion was using scripts to move snapshots to colder tiers, such as Glacier. But now they don't need to maintain scripts, and they have a secure end-to-end flow with our product. Finally, Druva is a partner that is integrating this product with their Cloud Ranger product so that they can provide cost-effective alternatives to their customers for archiving snapshots with reliable recovery mechanisms built in. So thank you. Now back to Ashish.
Yeah. Awesome, Venki. Thank you. We are extremely excited about Recycle Bin and Snapshots Archive. So again, a lot of your feedback went into those products. So we look forward to hearing what you do with them. Turning our attention to Data Lifecycle Manager, DLM. Again, Show of hands, how many use DLM today? Not enough. Okay. So with Data Lifecycle Manager, one of the things that we were looking to solve is what is a simple automated way to help customers back up the data that is stored on EBS volumes. And so what we built is the service called Amazon Data Lifecycle Manager. It helps you identify instances and volumes with the help of tags to create, to essentially back up and/or create armies. So both snapshots and armies are supported with Data Lifecycle Manager. You can define policies. We'll go into that. You can retain those backups for compliance and audit purposes. Again, part of the reason to create these policies is so you can, in a defined way, create and delete snapshots, which will help you save cost. And then you can use IAM policies to control access, and there is no cost to use DLM. So let's look at let's start with the basics of how to create a recycle bin or how to create a DLM policy. In this case, I want all EBS volumes attached to an EC2 instance to be backed once per day, saved for 7 days. And so there I have a tag with a vol type. I have a create policy that is every 24 hours. I have a start time. In this case, I picked 7 UTC. And then keep the most recent 7. So count of snapshots by lineage. Here's what it looks in the DLM console. You select the volumes, add the tags to the volume that you want to associate with the DLM policy. And then in the scheduling features, bunch of capabilities. It first asks you, do you want to target an instance or volume policy? The instance policy is where you get the multi-volume crash consistent snapshots. You can then put the tags that you want the backups to happen for. And then you can schedule snapshots either every hour up to 24 hours. In other words, you can reduce your recovery point objectives all the way up to 1 hour with Amazon with Data Lifecycle Manager. Okay, so then how do we help you on the policy side? So we've built now multiple schedules for your policy. So you can select multiple schedules. As an example, a very common pattern that we see with customers is they will create daily, weekly, monthly, and yearly snapshots. And so you can create those. One thing to remember, even if you have multiple policies, they're still part of the same lineage and still will have incrementality so that you save cost. And then you have flexible scheduling. So in addition to the daily, weekly, monthly, you can give your custom cron expression and then select how you want your snapshots to be taken. That's on the creation side. What about on the retention side? So we already looked at retention by count. We also added time-based retention. So you can now keep snapshots in terms of days, weeks, months, or years. And that way you can meet your time needs on snapshot retention. Then late last year, earlier this year, the DLM team added automation of copy across regions. They've also added support for copying snapshots across accounts and both together. And in addition, they've added support for armies. Again, if you are using snapshots and would like to have retention policies, highly recommend creating DLM policies. We see these used a lot across organizations as a way to standardize how frequently you want your snapshots taken. Again, please use it if you haven't already. Venki touched on direct APIs. What are those? Let's quickly dive through those. So direct APIs are a set of read and write access APIs to snapshots. So with the right APIs, you can create snapshots from any source. With the read APIs, you can list blocks, you can read blocks, and you can compare snapshots and read the change blocks. So what's the use case for writes and reads? So before the write APIs, if customers had on-premises block storage or data storage, your VMs, your databases, your file systems, they would replicate that data into Amazon S3. From there, create an EBS volume or an EC2 instance, and then start using snapshots to backup. As their data on-premises changed, they would update the snapshot, then update the volume again, and now create the next snapshot. Eventually, if you have to recover in a DR scenario or what have you, they would then use snapshot, or they would then use that snapshot to create a volume, or use fast snapshot restore to go create a volume. Okay? So what we changed is, with the right APIs, you can now replicate directly and create a snapshot directly. And from that snapshot, you can now use fast snapshot restore to recover in a DR scenario. And so you've taken away all the intermediate hops of copying it into S3, then creating an EBS volume, copying the delta set again, then refreshing the volume, and then retaking snapshots and recreating a volume. So all that becomes highly simplified with the right API scenario. What about reads? So this is true for a lot of use cases around backup, but also true around security scanning as an example. You have a volume. Customers would essentially want to record the change state of a volume. So in that case, they would take a baseline snapshot, snapshot A, take a second snapshot, snapshot B, which is at a later point in time, then spawn 2 different volumes, spawn an EC2 instance, and then do a diff compare of the 2 volumes to get the change blocks. We looked at this and said, this is pretty complex. And so instead, what we simplified that to is customers still take the volume, have a base snapshot, and have the next snapshot, so snapshot A and snapshot B. And now we just give you a simple API that compares those 2 snapshots, and you have the change blocks. So all of those intermediate steps around what you would need to do to get the backup delta set are just gone. So what are these APIs? The write snapshot API consists of 3 APIs. It's the start block snapshot. It's the put snapshot block, and it's a complete block snapshot. The start creates a snapshot. The put, you can write data into it. This is in individual block sizes of 512K. And then the complete block finalizes the snapshot, meaning that after that, the snapshot cannot be manipulated. Here's what that command looks like. Here's what the simple start command looks like, and here's the output for that start snapshot command. Then here's how you list the change blocks. This is the list change block command, where you would list the first snapshot ID, give the second snapshot ID, and then you would get the delta set between those. And then here's how you actually just do a read of the snapshot. You would do a get snapshot block, and you would get the output that you would put either in a file, in a different bucket, or wherever you want your data kept. And so again, these APIs are a simplifying tool, especially as you're building applications or are using them. You might consume them through your backup provider. A lot of them have integrated with these. But as you're thinking about snapshots, one of the things that we've realized is looking at snapshot as a backup primitive, and that's what these APIs are enabling you to do. So pretty excited about the journey there. The next capability is local snapshots on AWS Outposts. So for those that want a brief primer on Outposts, when we think about the cloud, we have the concept of regions. But customers, and we think that's the place for most use cases, but customers have good reasons why they want other places that they need the same level of infrastructure. One is for low latency reasons. Another is for data processing reasons. A third is for data residency reasons. And then there is the whole IoT and rugged edge conversation. A lot of that is a discussion that we've heard this week. So previously, when AWS Outposts launched 2 years ago, what we supported is EBS on Outposts. And then to take a snapshot, you would have to take a regional snapshot. So whatever region that particular outpost was parented to, you would store the snapshot in that region. Some customers came to us and said, well, what I really need is to meet my data residency requirements to be able to store the snapshot within an outpost. So we did 2 things. One, we launched S3 on Outposts, which allowed us to get S3 essentially within an Outpost context. And then we built EBS local snapshots on top of that outpost so that you can meet your data residency needs. So some considerations, right? EBS local snapshots. So these snapshots, by the way, we call EBS local snapshots versus regular snapshots, which we keep in region. We store snapshots of EBS volumes on Amazon S3 on Outpost. We create snapshots of EBS on Outpost with the same API CLI. We then copy snapshots and armies from region to Outpost. You can use DLM to create policies and manage that. You can also control access using IAM policies. And these snapshots, because they're in the Outpost context, are encrypted by default. So that continuum we looked at before of regions, followed by Outpost local zones wavelength, and then the rugged edge, we've now extended the framework of EBS in terms of GP2 and local snapshot also to an Outpost. So again, bringing that capability to you, this is a space we continue to learn more from and are super eager to understand sort of how you want to use it and where you want to take it. And so again, would love to hear your input on what we need to do there. Well, that brings us to the end of our discussion. Appreciate you guys taking the time. Appreciate you guys using AWS, EBS, and snapshots. But thank you so much for taking the time to listen to us. You can reach me on Twitter. I'm at LogicalBlock. And please, before you leave, do complete the survey. We love and appreciate all your feedback. On behalf of all of us, thank you.